Thank you for watching this Hexagon Geospatial eTraining module using point cloud editing tools in ERDAS IMAGINE. This eTraining module demonstrates how to easily identify, edit, and correct classification errors with an RGB encoded point cloud. This point cloud has been classified but has some areas of misclassification. This happens in certain areas when you use automatic classifications. Before beginning, note that the point size has been increased to point size 3 to better see the individual points. Let's see how to use the Select by Box tool. Let's start with a point cloud file loaded in the viewer. In this instance, we're using class rgb.las. From the Point Cloud tab next to Color By, select Classification. In the Contents panel, expand the 2D view layer to view the different classifications. Points in the same class have the same display color. The color red for the buildings makes it difficult to focus on the edges since the ground class color is brown and is so similar to red. To make a more clear distinction between the red building class and brown ground class, we'll use the Side View Profile View, the Front View Profile View, and the Select by Box tool. Select the building class. From the Point Cloud tab in the Style group, click Sea Level or Light Blue. Now the buildings are easily distinguished from the ground. Next, manually reclassify areas of misclassification. From the Point Cloud tab in the Profile group, select Rectangle Profile. Find a house that appears to have an error and was classified as vegetation. Draw a box around the house. The new view opens. The Side View Profile on top shows the side-to-side cross-section, and the Front View Profile below shows the front-to-back cross-section. Resize and rotate the profile box to show the house of interest. From the Edit group, click Select by Box. In the Side View Profile, draw a box around the points that appear to be incorrect. Select Reclassify from the Edit group. Verify that all the new class name fields are assigned as buildings. Click Apply and Close in the Reclassify dialog. Repeat the steps for the house next door. Again, verify that all the new class name fields are assigned as buildings before clicking Apply and close the Reclassify dialog. Next, we'll see how to reclassify using the Select by Region tool. In this example, we'll use pre-drawn houses in a particular area that are stored in a shapefile that will be the houses to be reclassified. From the Point Cloud tab in the Edit group, click Select by Polygon, Select by Region. A file selector opens. Select Class RGB Houses.shape and click Open. Notice the group of houses that are now white. This is the shapefile. Zoom in to enlarge the newly added shapefile. Click Reclassify to open the Reclassify dialog. Select all rows, right-click, and select 6 Building. Click Apply. Note that the group of houses is now blue. Finally, let's see how to reclassify using the Select by Area of Interest tool. To identify a particular type of land use or classification from a satellite raster image, you can create an area of interest, or AOI. The AOI in this image is comprised of a shape containing pixels of similar value or color to represent a particular type of land use. Here, we'll reclassify the points in the lake to represent water instead of ground. In the Contents panel, select the Winnipeg IMG layer. In the Raster section, select the Drawing tab and click Grow. Draw a box in the lake to create an AOI of pixels of similar value. In the Contents panel, right-click the newly created AOI and select Save Layer As. From the Save AOI As dialog, click Lake.aoi. Click Save. Close the Winnipeg IMG viewer. Now in the Point Cloud layer, we'll measure the elevation or Z value of the lake. Next, we'll reclassify all of the points at that elevation or lower to represent water. Click the Point Cloud tab. Click Rectangle Profile. Draw a box that includes part of the brown points in the lake, part of the black points in the lake, and some of the brown points on land. The Side View Profile and Front View Profile views open. In the Point Cloud tab, Profile group, click Measure Profile. In the Side View Profile view, click on the left side where the points are black and drag to the right to draw a line to the end of the black points. In the Side View Profile panel at the bottom, note that the NZ value is 229.229. This represents the elevation of the lake, 229.229 meters. Now let's set the Z value for all of the points on the lake to 229.229 meters. Click the Select by Region dropdown and select Select by Region. In the Region File Name dialog, select lake.aoi. Click Open. From the Point Cloud tab, select Constant. The Set Constant Z dialog opens. In the Set Constant Z Width field, enter 229.229. Click Apply and close. From the Edit group, select Reclassify. Select all rows, right-click in the new class name column and select 9 Water. Click Apply and close. Now all the points with an elevation of 229.229 are classified as water. In the Point Cloud tab, Profile group, click Delete to remove the side view and front view profiles. In the Home tab, Extent group, click Fit to Frame. In the Contents panel, expand the Class RGB.LAS layer. Here you can see the lake is dark blue, corresponding to the dark blue classification in the Contents panel. In the given examples, you are now able to identify errors and edit point clouds using the editing tools in ERDAS Imagine. Thank you for watching this e-training module from Hexagon Geospatial. For more e-training, please visit hexagongeospatial.com/e-training.